I welcome you all to the today's topic is about insulation coordination in the subject high voltage engineering. I am Radhakrishnan Sai Krishnan going to present this topic of TJ's Engineering College. Definition: the selection of suitable values of the insulation levels of the various components like transformer, circuit breaker, bus supports, etc. in any electrical systems and their arrangement in a rational manner is called insulation coordination. Let's We have seen the definition of insulation coordination. It's a quite simple manner. The electrical system insulation designs have to the insulation levels of components should withstand all kinds of over voltages. The protective devices should be installed at the sensitive point to limit over voltages for the safety purpose. Insulation level of an apparatus. It is a combination of power frequency and impulse voltage values. Let's see about the safety margin of insulation coordination. The difference between the voltage amp curves corresponding to protective devices and the device to be protected provides the safety margin for the insulation system. Now, let's see the necessity of insulation coordination. The necessity is to ensure reliability and continuity of the utility concern, to minimize the number of failures of lines and substations due to over voltages, to minimize the cost involved in the design, installation, and power of protective devices. To maintain the flashover should be minimum for insulator so that the system disturbance are less. Now let's see the insulation problems faced in the power system. The determination of line insulation should be considered. Selection of basic impulse insulation, that is BIL, and insulation levels of other equipments. Selection of lightning arresters should be considered. Now let's discuss about the ideal requirements of a protective devices. It should not using flashover of power frequency over voltages. The power time characteristics of the device must lie below the withstand voltage to protector apparatus or insulation. It should be capable of discharging high energies contained in surges and recover insulation strength quickly. It should not allow power frequency follow on current to follow. Now let's see the voltage time characteristics of insulation coordination. Proper insulation coordination would ensure that the volt time characteristics of the equipment will lie above the volt time characteristics of the protective devices. Now we are seeing in the diagram, you can see the diagram of the voltage, a graph of a voltage time characteristics of an insulation coordination, where the point A mentioned here is the transformer and B and C are the rod gap, where the D is a surge diverter and X is the critical slope. And the markings along the y-axis are surge voltages and the markings around the x-axis are time in microsecond. Now let's see the line insulation. The insulation of the line is based on the consideration of lightning and switching surges and power frequency over voltages. The line insulation must be provided to prevent a flashover due to the power frequency and switching surges, and also considering rain, dust, insulator power pollution factors. Overhead ground wires refused to protect the line and should be kept at proper distance above secondary line conductors. Now let's see about the surge arresters selections. The rate of rise of voltage should be considered in the selection of surge arresters. The type of systems are effectively grounded system and grounded through an impedance system, and the operating characters should be considered. The types of arresters are silicon carbide arresters with spark gap and silicon carbide arresters with current limiting gap, and the zinc oxide or gapless metal oxide arresters. Now let's see the VI characteristics of the arresters. In the silicon carbide arresters, V is equal to AIN, where in the ZNO, that means zinc oxide arresters, that is V is directly proportional to IN, and N is equal to 0.5 to 0.6, where in the ZNO N is equal to 0.02 to 0.30. The advantages of ZNO arresters: simple in constructions. The flat VI characteristics over an wide current range. Hence, we know that the voltage current characteristics of the ZNO, that is V is directly proportional to IN. The presence of spark gap that produces step voltage gradient when sparking occurs. Disadvantages of ZNO arresters, that means zinc oxide arresters: continuous flow of power frequency current, power loss is high. Location of lightning arresters: we should be consider the location of a lightning arrestor, where should be placed. The protective devices should be placed as close as possible to the apparatus is to be protected. That means the lightning arrestor should be placed as close as possible to the apparatus which must be prevented. Lightning arresters should be installed on the transformer terminals. This is the equivalent circuit of a surge arresters. The protected devices is to be connected between the terminal A and B. You can see this diagram, and where the point A and B, this is a circuit diagram of Thevenin's circuit, where the protective devices is being placed in between the point A and B. Hence, the equation is being formed that V is equal to 2 into R plus R into R plus Z into U of t, where there capital R stands for resistance of non-linear elements, where the small r stands for ground to earth resistance, where the U of t is the surge voltage. Through this equation, we can find the voltage along the surge arrestor. The equipment installation level, that means the distance of an arrestor location, stiffness of a wavefront, electrical apparatus. The BIL should be of 1.25 to 1.3 times protective level offered by surge arresters. The insulation coordination in EHV and UHV systems. The stations have transformers and other valuable equipments that have non-self restoring insulation, that is given by an equation, that is SIL is equal to modulus of VRL whole square divided by Z in the megawatt, where Z stands for root of L divided by C, whereas VRL is the line voltage. Thank you, friends. I complete my topic. Thank you all.